On to our next question. We are asked for the Lewis structure of PBr3. And so let's begin by counting our valence electrons. And so for our valence electrons, we will have 5 from the phosphorus and 3 by 7 from the bromine. We can, as usual, name these phosphorus Br3. And this will just give us 21 plus 5, which is 26 electrons to play with. The question said I can assign lone pairs and radical electrons where appropriate and admit atomic charges. From here we can see that this is an even number, so we're not going to have any radicals. And so there are no radical electrons. And so we'll just have lone pairs and bonding pairs. Let's go ahead and create our skeleton. We're going to have P in the middle, and then Br, Br, Br. If you'd like to know why I've chosen P as the central, we know that the central atom should be the one that can make the most bonds. We can calculate how many bonds each one of them can make. The bromine can make 8 minus the valence electron, so that's 8 minus 7, so each can make 1 bond. Meanwhile, the phosphorus can make 8 minus 5, so 3 bonds. And so it can make more bonds, so it should be the central. Next up, let's fill in our octet on the bromines. And then let's see if we have any electrons left to stick on the phosphorus. So we have 2, 4, 6 on each of the bromines. So 6 by 3 plus 2, 4, 6. And that is going to give us 24 electrons. So we have 2 more electrons that we can stick on the phosphorus like that. And so our valence electrons are all accounted for now. Let's double check on our formal charges. For the bromine, we'll have 7 minus 6 minus 2 over 2. So 7 minus 7, that's going to give us 0. On the phosphorus, we can have 5 minus 2 minus 6 over 2. That is going to give us 5 minus 5, and that is also going to be 0. So our formal charges make sense. We have a net charge of 0 as expected, and our valence electrons are all accounted for, meaning that this is going to be our final structure.